Here is the answer for the round 33 day 2 Bauerk. Lead 2 sulfide has a Ksp value of 3.0 times 10 to the negative 28 power. What is the concentration of lead ions in a saturated solution of lead sulfide at 25 degrees Celsius? To do this question, which involves Ksp and concentrations of dissolved ions, you need the general formula for Ksp, and here it is written here. Ksp is equal to the concentration of one of the ions raised to an exponent that is the coefficient in the balanced equation, multiplied by the concentration of the second ion raised to an exponent that is its coefficient in the balanced equation. So this formula refers to using coefficients as exponents. So in step 1, let's get that dissociation equation. Let's just simply show what's created when lead sulfide solid dissolves. It breaks up into lead ions and sulfide ions in a 1-to-1 ratio. And these ones end up being those exponents. Next, let's take that general equation written in blue ink and make some substitutions to make it fit our exact situation that involves lead and sulfide ions. So where the capital A is, we'll replace that with Pb positive 2, and where the capital B is in general, we'll replace it with S negative 2. And again, our exponents happen to be 1s because our coefficients in the equations are 1s. Furthermore, because the ions are in a 1-to-1 ratio, we know that the concentration of lead ions is simply equal to the concentration of sulfide ions. In step 2, we'll make substitutions into our general equation. So at this point in time, this is just a pure algebra problem, doing our normal algebra steps, substituting numbers and then solving for things. I've rewritten the general equation, but then you see in the next line, numbers are substituted in. So from the story, we were given the value of Ksp. That number is filled in on the left side of the equals, and we've replaced capital A with the symbol for lead ions, replaced capital B with the symbol for the sulfide ions, and then because we knew that the concentration of lead was equal to the concentration of sulfide, I've made this substitution here, and this is the key step in the problem. Because now we can solve this equation by removing the exponent of 2, removing the squaring by doing a square root. So when you take the square root of the Pb positive 2 squared, it just makes Pb positive 2. And when you take the square root of this value here on the left side of the equation, it happens to make on a calculator 1.7 times 10 to the negative 14. The brackets are the symbol for concentration of something, and our concentration is measured with molarity.